So Simpson 3 over 8. So Simpson 3 over 8 compared to trapezoidal basics 1 segment, Simpson 1/3 basic 2 segment, and then Simpson 3 over 8 basic you must have 1, 2, 3 segments. Okay, these 3 segments later on will denote as a A1. So mean each A1 in Simpson 3 over 8 is 3 segment. Okay, and is estimate using this formula. Also we show it without derivation, which is mean the basics formula for Simpson 3 over 8. Actually you have the formula which is 3h over 8. That's why 3 why the name Simpson 3 over 8. So 3 over 8h fx naught plus 3 times fx1. So fx1 here. So you have Simpson 3 over 8, 3 segment 4 point, x naught, x1, x2, x3. Okay. So this is f1, this is f2, this is a f3, this is a f naught. If you estimate fx dx from a to b, which is the basic application is an area using Simpson 3 over 8 with 3 segment, mean the basic Simpson 3 over 8 is estimate using the formula 3h over 8 multiply f naught 1 time, f1 3 time, f2 3 time, f3 1 time. So mean intermediate f is actually 3 time, 3 time. So of course if we use 3 segment, you see the blue color means Simpson 3 over 8 is actually estimate using that's not quadratic, this is a cubic curve. It's estimate using the cubic curve. So you can see is this this part suppose not included, this part also not included, but this part should be included. That's why the error still there. But compared to 1 segment of trapezoid or 2 segment of Simpson 1/3, Simpson 3 over 8, you have 3 method now. Simpson 3 over 8 is always the best the best method because it is cubic approximation, because it's estimate 4 point, you have a cubic curve. So Simpson 1/3 you have only 2 segment, 3 data point is a quadratic curve. And trapezoidal is they connect it straight line. So compare these 3 methods, Simpson 3 over 8 is the best, followed by Simpson 1/3 and then trapezoidal rule. So you see the basic structure for Simpson 3 over 8 is 3. So from 3 you may extend it to, you duplicate 3, 6, 9, 12, 15, and it's always multiple of 3. Mean the n should be always multiple of 3. So n is 3 times of m. So same thing, h is b minus a divided by n. And you see here, for a1 must be 3 segment, f0, f1, f2, f3. 3 segments, so 4 data point. So another A2, 1, 2, 3, 3 segment. Up to the AN, 1, 2, 3, 3 segment. The F there, Fn minus 2, Fn minus 1. And then you have a F. Connect together. This is Fn, Fn minus 1, Fn minus 2, Fn minus 3. Using the basic formula, A1 is actually x0 up to x3. Because you have 4 segment, 3 segment, 4 point, x0 up to x3. When you estimate from x0 up to x3, fx dx, the formula is 3h over 8 F0 plus 3 times F1 plus 3 times F2 plus 1 times F3. This is a basic formula. So we are going to apply this basic formula to the area 2, area 3 up to area n. So area 1, x0 to x3, okay, which is the basic formula here. 3 over 8h f0 plus 3f1 plus 3f2 plus f3. And then from 3 to 6, 3, 4, 5, 6, total 4 points there. So estimate using the basic formula. Again, you have 3h over 8. Start from 3 to 6. So starting, ending f is 1 time. F3 1 time, F6 1 time. Intermediate f 4, 5, 3 time. Okay, up to the last an, this an. So you have this is fn. Okay, and then front will be fn minus 1, fn minus 2, fn minus 3. So starting, ending f is 1 time. Intermediate f is 3 time. Then you got 3h over 8. So again, you factor out 3h over 8 in each term you have here. Mean the integral of fx dx from a to b can be approximated using composite Simpson 3 over 8. Basics is only here, x0 to x3. This is more than 3 segments. So you notice against f0, fn, 1 time only. 1 time only. This is what we put in the first column. F0, Fn for trapezoidal, Simpson 1/3, Simpson 308 is the same in the first column, only 1 time. Then you see you have 3F1, 3F2, 3F4, 3F5. Okay, and then here 3F1, 3F2, 3F4, 3F5. 3 times fn minus 2, 3 times fn minus 1. So you see all the 3 times of the f is actually, which is not multiple of 3. You see, 3 times f, 3i minus 2. 3i minus 2, okay, plus 3i minus 1. Okay, when I is 1 up to n divided by 3. Okay, so 3i minus 2, when I is 1, 3 minus 2, we have 1. Okay, and then 3 minus 1, you have 2. So I equal to 2. When I equal to 2, so you get F4, F5, and so on. And you notice this one, okay, what we call here, this one, yeah, you cannot see. Other colors. Here, F3 1 time, F6 1 time. Okay, if you have one more here, this is 3h over 8, 6, so this is 7, 3 times F8, 3 times, sorry, 6. They are connecting 6 and 6. 6 and 6. So this is 7, this is 8, this is F9. You see, 0, 1, 2, 3, up to 3. So this is up to 6, this is up to 9. So you see F3 and this F3, 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 2 times. F6, F6, 2 times. This F9, if you have another one, this would be A3, A1, A2. If you do A4, then F9 will add up with this F9. So you notice that, okay, 2 times summation F3i. 3i is actually multiple of 3. F, which is multiple of 3, is actually in the third column, multiplied by 2. Because here, F3 1 time, F3 1 time, 2 times. F6, F6 1 time. Here, F9, if you do it another one, you have F9 here. Mean F9, F9. So this one is F12. F12 will connect with another F12 here. So F, which is multiple of 3, is actually you count, okay, you sum it 2 times. That's why 2 times summation of f, which is multiple of 3. And f, which is not multiple of 3, is only 3 times. Is 3 times. Hence, okay, the same technique, okay, the same integral. Now we are going to estimate using Simpson 3/8 rule with n equal to 8, like example 6.1 and 6.2 just now. Okay, okay, you notice here n equal to 8. Can you use Simpson 3/8 rule or not? Simpson 3/8, minimum n is 3, from 3 up to 6 and then 9. So when n is 8, cannot be used, because it must be multiple of 3. So that's why this one cannot be solved using Simpson 3/8. So the questions, okay, they may give you, okay, approximate this integral using suitable, okay, either you want to, okay, n equal to 8, then you can use trapezoidal rule, you can use Simpson 1/3, but you cannot use Simpson 3/8. So that will be, okay, higher level question. Okay, now if n equal to 9, then you can use Simpson 3/8 rule. Okay, but can you, okay, example 6.6, can you approximate it using trapezoidal rule? Okay, can you estimate it using trapezoidal rule? Aiyo. Okay, sorry. I think again, I think they said the TCIS cannot, okay, go in through the Chrome clash, but I forgot. Okay, sorry. The whole Chrome close again. They said it's actually clash with the TCIS. Okay, but okay, don't worry, you can watch back the recorded video. This one is recorded, but just now Simpson 1/3 forgot the record.
Doctor.
Yes, yes.
Actually, you left the meeting.
Yeah, I just realized the Chrome automatically close everything. And then I just
Oh, okay,
realized
okay.
when I want to ask question, then already left. So it means, okay, from beginning there, I don't know which part that I left, but don't worry, okay? It's the same thing, only the formula different. Okay, only the formula different. Okay, look back this one. Okay, basically here, let's revise again. Okay, using Simpson 3/8 rule, the formula is 3h/8 f naught plus fn. This is the first sum. Okay, second sum is actually f, which is not multiple of 3. Yo, next, yeah, next time cannot use. Then I just revise from the formula here. Hey, troublesome, cannot write. Okay, this one mean for Simpson 3/8 still has still have a 3 column. First column is same is
Doctor, can you share
yes,
screen?
yes.
Can you share screen?
Oh, I share screen.
Yeah. Doctor forgot to share screen.
Okay, so the derivation, you can watch back the video later on. The formula for Simpson 3 over x rule, 3h over 8 f naught plus fn. Okay, this is the first sum in the first column. Second column is f, which is not multiple of 3. Here, f1, f2. You see, f4, f5, which is f not multiple of 3. 7, 8. Okay, you have here 10, 11. Second column, 3, okay, 3 times for f not multiple of 3. The third column, where f is a multiple of 3, because f3, f3, 2 times. f6, f6 here. f9, f9 here. If f12 with the next a, you have a f9. Okay, and Simpson, okay, Simpson 3 over 8, make sure, okay, the basic structure is, okay, the basic structure is 3 segment. Here, 3 segment. 3 segment, this is indicate as A1. A1 is 3h over 8 f naught plus 3f1 plus 3f2 plus f3. And then from 3 segment, you can double become 6, 9, 12, 15. It's always multiple of 3. Trapezoidal rule, no n can be odd or even. 1/3 is even number. Simpson 3 over 8 must be multiple of 3. Okay, so with this, okay, we have the same integral as in example 6.1, okay, using trapezoidal rule. 6.2 using Simpson 1/3 rule with the same n equal to 8. Since n equal to 8, Simpson 3 over 8 must be, the n must be multiple of 3. So 8 is not multiple of 3, hence it cannot be solved using Simpson 3 over 8 rule. So, okay, this is what we call high level of question. From the n given, you have to see whether, okay, Simpson 1/3 or Simpson 3 8 is suitable. Okay, trapezoidal rule, okay, no condition. You can use up all even or odd, okay, and Simpson 1/3 must be even number. Simpson 3 over 8 must be multiple of 3. So example 6.5 cannot be, okay, cannot be solved using Simpson 3 over 8. Now we look at example 6.6. So n is 9, n is 9. So it's a multiple of 3, so we can solve using Simpson 3 over 8 rule. Okay, how about, okay, can we solve it using Simpson 1/3 or not? Okay, can we solve it using Simpson 1/3? Okay, check whether you understand. Afif, Aiman. That's why I see whether you are follow or not. Okay, can somebody respond? Can you solve it using Simpson 1/3 for example 6.6?
Cannot.
Cannot, doctor.
Yeah, so mean you understand. How about trapezoidal rule?
Can.
Yeah, so mean at least you understand. Okay, so after that, given n, you can go to find the h. Okay, h is a b minus a divide n. So b is upper limit 0 minus negative 2 divide 9. So you have 2 over 9. Okay, and then, okay, first of all, show you using the calculator. Where's the calculator? Calculator. Okay, go, you can always check it, the integral, the exact solution here before you proceed to your numerical method. From negative 2 to 0. Okay, exact is 1.4338. So you can jot down. Yeah. 1.4338. This is exact solution. 1.4338. Okay, now you know the starting ending h. You can tabulate using the table menu. Menu number 9. Okay, so it's 1 plus shift exponent of x. Yeah. Okay, gx let 0. Starting is a lower limit which is -2, and okay, n is a upper limit which is 0. Step side is a h. Okay, 2 divide 9. So you get here. Transfer to Simpson 3/8 rule table. Here, this is tabulate the x and then put it into the Simpson 3/8 rule. Here, there's a calculator. Here. So you move it. Okay, start F naught Fn, first column. Second column is F not multiple of 3. Refer to the I here. 1, 2. Second column. Row number 3 here. Third column. 6 here. 9, because it's an ending F, so put in the first column. Sum it. Okay, after sum it, okay, you can check the value. Correct. 7, 9. Okay, when you see the value, read at the bottom here. If you read here, 0.7913 at the bottom one. So take the value at the bottom. X6, round it is okay to 4 decimal place 0.7087. Then put in so fast. Put into the formula of Simpson 3/8. So 3/8 times h, which is the h is 2/9. Okay, you take fraction better, then you take the floating point. F naught Fn is here. 3 times F, which is not multiple of 3. Here, this one. 2 times F, which is multiple of 3. Then calculate in one step. Where's calculator? Calculate in one step. And you will calculate like here. 3 divide 8 times 2 divide 9. Okay, and then bracket. F naught Fn is 1.3808 plus 3 times. In second column is 3 times 4.3067. Okay, the last column 2 times, same with Simpson 1/3, 2 times 1.4522. Calculate in one step, so you get 1.4338. Okay, compare with the exact solution just now. Exact solution. 1.4338. So the error is actually 0. This is Simpson 3/8. Simpson 3/8, the formula is 3/8h. Simpson 1/3 is 1/3 h. First column is sum of F naught Fn. Okay, and for Simpson 1/3, the third column is 2 times. The coefficient is 2 times. Second column is 4 times. But the second column for Simpson 1/3 is odd F. Third column is even F. Simpson 3/8, second column is F not multiple of 3. And third column is F, which is multiple of 3. So n equal to 9, the I will end up with 9 here. So this is Simpson 3/8 rule. Okay, if you want to perform in Excel, it's the same thing. Let me see. show you the question. Okay, B, copy it here. B is where? B is upper limit 0. A is lower limit -2. Okay, this given n is given what? N is 9. Given n 9, then calculate h. Okay, h will be your B minus A divide B minus A, make sure bracket, then divide backslash, divide the n. Divide n. Sorry, B, I click wrongly. Divide F3. Okay, so this is a H. You have I. Okay, X, and then F here. I is from 0, 1, up to 9. So n equal to 9, then the I end up with 9. This is the X, this is the F. Okay. Okay, X, okay, X naught is -2, or you can equal to A here. X1 is a X naught plus H. Okay, you click the location of H, make sure you constant it because you want to copy it down. Okay, and then key in the function for F is 1 divide. Okay, denominator, you got 2 terms, make sure you put bracket 1 plus. Exponent is exp. X, click the location of the X. Sometimes you cannot click, then you type the location is B10. B10. Close the bracket for exponent, close the bracket for the denominator. Enter. Okay, this one I didn't round anything. Okay, if you want to round also can, then you can have a same answer with the manual calculation where you round it to 4 decimal place. Now I round it. Okay, and then I drag down. Then I move the intermediate F to second column first. Okay, and then 1, 2, the third one I move here. 1, 2, the third. Okay, so you can see this is row 3, this is row 6. Okay, so now it's correct. Okay, I will sum it. Okay, sum, make sure it, so you drag it to include all the range that you want to sum. Okay, and then point to the right bottom, copy to get sum 1, sum 2. Then the answer is actually you have 3/8 time H here time bracket sum 1 time. Okay, and then the intermediate column 3 times for Simpson. Okay, 3/x rule. The last column of the sum is a 2 time. Here, so if round to 4 decimal place, 4338. Okay, compare with here. Okay.
Doctor,
The wrong function.
is it the decimal point for our last answer? Is it have a issue about the place for the answer, the decimal point? 3 or 4, we take it from the decimal point.
Okay, it may not, we use 4 decimal place. Okay, I see whether I Oh,
If I take it only the 3 decimal place, is it okay?
okay. In the instruction, you follow the instruction normally. Okay, you see if they want 4, you have to use 4, because if you 3 later on, the answer run a little bit.
If it's not mentioned about it,
It mentions.
or still mentioned, okay.
Yeah.
Thank you.
Which one I test? Just now. This one, right? And then the answer. I think I provide the wrong answer. 4338. Yeah. 43. If round it, okay. Now this one is round. If I round, okay, you will see the answer should be okay tally with the manual calculation. If I didn't round, you see the F here more than 4 decimal place, and the last value here you sometimes run, even not round, because if you didn't round, Excel take more than 4 decimal place is actually better, more accurate. But to check it, whether tally with your manual calculation with 4 decimal place, that's why here I round it. So the last step, this one, if you round it, 4338. So same. Yeah. Okay. And then the last one here also same. Only the function chain. Okay. Same thing. Approximate the integral x over square root 1 plus exponent x dx by Simpson one-third rule with h equal to 0.25. Okay. Simpson. Sorry. Should be 3 over 8. Because I think copy paste from the Simpsons rule example there. Okay, this one please please change it to Simpson 3 over 8. 3 over 8 rule. So the n is actually b minus a, 2 minus negative 1 is 3. Divide 0.25, you get 12. Because you got 3 divide 1/4 is 12. Okay, so 12 here is a even number. Then you can solve it using Simpson one-third. And you can also solve 12 is also multiple of 3. Hence, you can also solve it using Simpson 3 over 8 rule. And it always can be solved using trapezoidal rule. So you tabulate the function, okay, put into the Simpson 3 over x rule. Okay, so this is a sum here. Then you put accordingly to the formula. Okay, and you will get this answer. This is okay from the calculator, the exact solution. You can check back if Simpson wanted just now. I think also the same answer, right? Because we round it 4 decimal place. Okay, Simpson wanted. Checking Simpson wanted. Not this one. 2, 3. This one. 5143. 5143. Example 6.3 and here 6.7. 0.5143. Both method give the absolute error of 0. So you just tabulate. Okay, if just now Simpson wanted odd f in second column, now Simpson 3 over 8, all the f which is not multiple of 3 in second column. Okay, and then third column is a f which is multiple of 3. So f3, f6, f9. f12 is the last f, go to the first column. Sum it, okay, and then here put it 3 over 8 times h, which is 0.25. Okay, first sum is negative 0.1645. Second sum for Simpson 3 over 8 is 3 times. The last sum is 2 times. You get 0.5143. Okay, we can check back using Excel just now. I think sheet 2, sheet 1. This one. Compare using, this is Simpson one-third. Just put one-third. One-third. Yeah, why not? just want to enroll at the end of the class. Afiq Aiman. Okay, I Control C, Control V. Okay, chain it. Okay, Simpson 3/8. Okay, you see running. Okay, why the answer here run? Because what? B11. Correct. Square x divide square root 1 plus x, correct? Why the answer different? Why the f here run? Because the x here should be -1 to 2. Why now becomes 0 to 3? Okay, so when you copy it, be careful. Because in the Simpson 1/3 table, okay, x naught, I click it equal to G2. G2, and then you see 1, 2, 3, 4, 5. Okay, this is a 6 column. So it run 1, 2, 3, 4, 5, 6. This is what we call relative column. So when you copy it, it follow the pattern, it run. From x naught here, just now A is here. So x naught in Simpson 1/3 to x naught in Simpson 3/8, there's a gap 1, 2, 3, 4, 5, 6. So you 1, 2, 3, 4, 5, 6, it run. Okay, so you drag it back. Okay, so now you drag it back, correct, because h here is constant. So when you copy it, it wouldn't run. Constant. Constant, you see dollar front and back at the column label. So when you put constant, you copy it to any place, it maintain to the same, okay, the same location, it would run. Okay, so now everything correct. Okay, I need to move to the correct cell. Uh, 6 correct here. 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9, move to here. 10, move to here. 10, 11, 12 here. So you see, I copied from Simpson 1/3 table. I just copied to get Simpson 3/8, and then edit the F to the correct column, and the sums there, it follow the pattern. It will automatically sum it. So everything is correct there. To double check, you just click and see whether it sum it correctly. Okay, answer is wrong. Okay, because it got 3. Okay, again M3. See M3 running. Because just now when I key in the formula for Simpson 1/3 H, I didn't make it constant, so it will run. Okay, here 1, 2, 3, 4, 5. So you run it. Okay, here 1, 2, 3, 4, 5 to here 6. So it run accordingly to number of column. Okay, and then you have to make the changes, correct it back. This is a H. Okay, and then is H. You have 3 times H divide 8. 3/8 H. Okay, and it's 3 intermediate F is 3 times. So now you get, okay, if round to 4 decimal place, OUND, open bracket, then comma 4. This is round to 4 decimal place, then we'll get both same answer. This one also, if you round, after equal, you key in ROUND. For any function in Excel, you open bracket, okay, and then comma here. Mean we'll round this expression separate by comma using 4 decimal place. So when I round it to 4 decimal place, both are same. If you didn't round, then you can see, there are actually some difference there. But when you round to 4 decimal place, both are same value at the 4 decimal place. So this is Simpson 3/8. So you see Simpson 1/3, Simpson 3/8. Here, if you want to solve using trapezoidal rule, also can, because trapezoidal rule, okay, no condition at all. Okay, trapezoidal rule again, I can copy, but it will run. Okay, now it run again because here the A M2 running. Okay, trapezoidal rule. Okay, put everything into the the intermediate F to second column. This one no need. Okay, and then here trapezoidal rule is h over 2. Okay, and h, okay, here h over 2 time intermediate F G3 over 2 here h over 2 plus O24 is first sum, okay, plus 2 time, okay, second sum. So you see the trapezoidal rule, okay, have a more error because the exact, okay, at 4 decimal place should be 0.5143. So you can see that trapezoidal rule is not that good, okay, to estimate the integral unless you have smaller h. So this is okay. So we have 2 hours finish. Okay, trapezoidal rule actually not in the syllabus. Your syllabus is only Simpson 1/3 and Simpson 3/8.